Here's a Philips black and white solid state TV from maybe late 60s, early 70s, I guess. Somebody gave this to me and I'm not sure if I'm going to scrap it or keep it. It has a lot of problems with bad electrolytic capacitors. This resistor here is smoking badly, and I already tried disconnecting this one, disconnecting this guy, and replacing the resistor made the TV work with a very dim raster, I guess probably because of the low B plus and the ripple that it would cause. But then another resistor over here, this one in the audio section, started smoking. We had a exploding boost filter, which I don't know where it is. Not this one. I don't remember where it is in the circuit, but it popped and we lost a high voltage. We got a lot of recapping to do on this TV, and I'm not sure if it's worth it. I'm not sure if it's worth it yet, because this is too modern for my taste. It has integrated circuits. The sound IF and preamp is in an IC. We got horizontal oscillator IC. The IF and the sync is also integrated circuits. The vertical is all discrete transistors. The audio output, of course, is discrete transistors. We got a couple more over there on the power supply, and this thing uses those germanium metal transistors that form the whiskers, and they short. I don't like that. I don't like those, so I bought a new toy. This is a Mutter BMR 95 Crt Tester, which I'm going to try now for the first time. We're going to test the Crt on this, because I could only produce a very dim raster. If the Crt checks good, I'm going to keep the TV. Maybe in a couple of years I have the motivation to recap it. Let's see. Okay, so plastic cabinet with fake wood grain. It's actually in very nice condition. I don't like this. Plastic back cover held in with snaps. I also don't like that. What I do like about this, and most Holland made and German made TVs, is this. You can hinge the chassis like this. You can do some work here, but then you can do this. You can hinge it like that, and it actually does not touch the table. So you can turn on the TV and work on it at the same time. If you do it like this, you can work in the back of the circuit board with the set on. You don't have to worry about lead dress, because it's all packed in bundles, so very easily serviceable, like most of the Philips TVs. The electrolytic capacitors are encased in these blue plastic sleeves, which is kind of nice. Unfortunately, these small metal electrolytics from this era used on the Philips TVs, they're all bad. None of these will test good, so I would have a lot of recapping here to do for what this TV is, which is really not of my interest at this time. Got here a printed power resistor which blew off. It is a ceramic tile with printed carbon track on top. It's held on this big ass heatsink, so it must dissipate quite quite a lot of heat. Got there your main filter, flyback, nice epoxy overwind. Here this bunch of potentiometers all bundled together is the vertical section. We actually don't seem to have any sort of transformer. This is the yoke plug. That's probably the oscillator in the output, or the opposite, I don't know. VHF and UHF tuners, IF stage. These are the audio output transistors. Yeah. Okay, so let's check the condition of the CRT. So the label is torn, of course. Every single TV that I own either has a chassis number erased or the label's torn, so that makes it difficult for me to troubleshoot. But according to the schematic, we can have three different CRT types: A61, A50 and A44-120W. So I think they are identical with the exception of the size. Let's see. Okay, so both three of those types use the number 801 adapter. A44-120W uses the adapter number 801. So the way this tester works is you don't have a filament voltage selection available. The filament voltage is selected automatically by the adapter that you use. So it's just a matter of plugging in this thing to the CRT, setting the cutoff, and we should read the emission over here. So the first thing you do is test for shorts. Just press this button. No deflection on the needles. And the lights are not coming on, so no shorts. Okay, so cut off. Switch to minimum. There you go. You're supposed to set this thing up over there on 0.05 milliamps, and we have 250 volts. It sounds correct. Now emission. It's dropping. Why is this thing dropping? So a good CRT is supposed to read 0.7 milliamps. So yeah, this thing's a little bit jumpy. Let's see if I can tap. It's climbing. Okay, I'm going to let it run for a while. So after about 30 seconds or so, we are almost at 1 milliamp. That looks to me like a very strong CRT. The needle's a little bit jumpy because we actually have some poor contacts in this plug. See there? Now it goes back up again. And you check that. But we're at practically 1 milliamp. That's really good. A good cathode is supposed to read 0.7 according to the tester manual. So I'm going to keep this TV till I have the motivation to repair it. Now I have another CRT that I want to test that I think it's dead. So here's the Telefunken AW53-80, and this is almost dead. It displays a very dim picture when you have the brightness and contrast all the way up, and if you back off the brightness just a little bit, the picture goes away and you can only see it in a very dim room. So I kept it because I don't like to throw anything away, but it has no use. And the problem is not the TV, because I put in a 17-inch, this is a 19-inch or a 21, I don't know, and I put in a 17-inch tube and the TV works fine. So I don't have, on my tester, I don't have the adapter for this Crt type, but I have here the pinout for this Crt, and that is the pinout for this adapter. So I improvised a little bit here with some jumper wires. The heater is glowing, but I have the cutoff in maximum and there is absolutely nothing there. If I switch to emission, we have just a little bit of needle deflection. Look, just that tiny bit. And this thing is on for about 2 or 3 minutes, so had plenty of time to warm up. It usually doesn't take longer than a minute, even on a tired tube. So I've already tried baking it with 9 volts for a couple of hours on the filaments. I've already tried the rejuvenation using a 15-watt light bulb, plugging G1 and cathode to the mains with a 15-watt refrigerator light bulb in series. That caused a bunch of flashes here, like it's supposed to do. The brightness improved just a little bit, but it's not usable. So there you go, a little bit of emission there. So I'm going to try the regeneration just for fun. I'm sure it will not do anything useful, and we'll see if that improves the emission on this thing. I don't know if there will be sparks there, but I'm going to turn off the lights just for fun. I see something glowing there. So we have a spark. Okay, let's see. Well, I don't believe this thing. So it's the same Crt connected to the same tester. We actually have cutoff now. I think I can switch it to 500. Yes, I do. We have cutoff. No. Switch to 700. Yes. Now emission. Look at that. I don't believe this thing. This is testing like a very strong tube. I think this is too good to be true. Really. So what I need to do now is I've got myself into a whole bunch of trouble, because this tube belongs in my living room console. It's a hi-fi stereo Normandy radio with a turntable, and I added an auxiliary input for the cell phone, and it has a TV. So the TV has this thing, but since it was dead, I fitted a smaller tube. I added a smaller mask and did some modifications, a new strap, and I have there the small tube. So now that this thing supposedly has emission, I need to swap it back and try it out. So I really got myself into, I was here spending some time, and now I got myself a whole lot of trouble because I want to put this thing back on the TV and see if it performs like it says here. This is unbelievable. And it was just a soft spark, because when I tried rejuvenating it with the light bulb, there was a whole fireworks show inside of that neck, and it did not improve picture quality very much. But this thing, I mean, I don't believe it. We have a live test here. I'm not sure how it works, but I may try it. Let's see what it does. Okay, yeah, I remember reading in the manual that when clicking the live test, a strong tube would show a moderate increase in current, and a weak tube would show a large fluctuation. So it did show a large fluctuation, but yeah. But I mean, 1 milliamp, you gotta be kidding. This thing was dead. We didn't even have any cutoff. Let's see if it drops back to 1 milliamp again. It actually got even stronger after the live test. What the hell is this? I think I will be disappointed once I fit this in the TV, but maybe not. Okay, cutoff is a little bit high. It's supposed to be set on 0.05 milliamps. Right there. Emission. Yeah, 1 milliamp. Oh my god. Okay, so if you are following my channel if you are viewing my videos to follow my Philco Predictor restoration series, I want you to know that the TV is already done. It's ready. It's working very well. I have some footage of the final stuff that I made. I have some footage of the set working, and I'm going to cut some parts and glue glue them one to the others to make the video, and I will be uploading it maybe tomorrow or in the next few days. I had some spare time today from work. Unfortunately, this has been a very not so great month. I don't have a lot of work, so that's good because I have more time to do these things. But it's not good for my finances. But yeah, I had some spare time today, and I'm here playing with this thing, and I hope you enjoyed it. Okay, so let's try this one more time. I let it cool down. It's already cool. Here on cutoff. Let's turn it on again and see if it still reads something. It's glowing. Let's wait another minute or so. Okay, 30 seconds have passed, and yes, we still have cutoff. Emission. Not so great this time, but it's climbing. It's steadily climbing. Yeah, it's climbing. Okay, I'm going to wait another minute. Okay, so that was too good to be true, and sure enough, it was not true. So I turned it off, let it cool down, turn it on again, turn it off again, let it cool down, and it seems to have settled right there. 0.65 milliamps. So still impressive because it was completely dead. and it's here in the area that says good, which means good. And according to the manual, a strong tube will read 0.7, so we are almost at 0.7 now, and it seems to want to creep up a bit as it warms up. So I don't know. I think it's worth to try this tube in the television. I think it will display a usable picture, and then I can harvest back my 17-inch tube, which will go in another TV set that I have that needs it. So yeah, impressive device, this thing. And we have here something else. See this anode cap? So this thing also has a focus test. It tests the focus on the CRT. And besides that, we have something called, where it is, this thing right here, which is the Flash EX. And what this thing does, supposedly, you connect it here, you connect it to the neck of the tube, you connect the anode cap onto here, and you put it on, where do you put it? Well, I don't remember on which mode you set it, but supposedly it does something inside the tube to help remove the gas that may be inside of it. So it helps to reflash the getter or something like that. On the manual it says that the gas particles will be stuck to the metal parts and to the getter itself. It says that it will help tubes that are gassy, and that it can only be made a limited number of times until the getter is all used up. So I never tried that. I'm not gonna try it on this one, but if anybody knows in detail how that works, you can comment. And yeah, it seems to have stopped there on 0.7. 0.7 is very good. Very good. We'll see. I'm going to put it in the TV and we'll see, but not today. Thank you.